Hi my dear students, today we are going to discuss about the mean value theorem of calculus. This is especially for the engineering students or school level students, those who are studying their calculus, the applications of calculus. And it is a mean value theorem. In this mean value theorem, we have to check three conditions. Number one, the f of x should be defined, right, and continuous on a closed interval a comma b, and the derivative f dash of x also should be defined at the open interval a comma b. The third condition of the Rolle's theorem is not needed, that f of a is equal to f of b is not needed. Then there exists at least one point c belongs to the open interval a comma b, such that f dash of c is equal to f of b minus f of a divided by b minus a. b minus a is the rule of mean value theorem. And if you want to express this graphically, consider that function in which you will be having 2 points. This is a and this is b. So this is a comma f of a, and this is b comma f of b. You will be getting a line joining these 2 points. And as per the mean value theorem, you will be having another point c belongs to this a and b. In between this a and b, in which you will be getting a parallel line to the above line. You will be getting a parallel line to the above line is the concept of the mean value theorem. Parallel line means the slopes are equal. Actually, this f of b minus f of a divided by b minus a is nothing but y2 minus y1 divided by x2 minus x1, which is the slope of the given line, and hence f dash of c become the slope at a particular point. Hence that become the same idea. Now let's discuss the problem for explaining the mean value theorem. Consider your function f of x is equal to x power 3 minus 2x plus 5, which interval we can take for example 0, 3, the closed interval. We have to verify the mean value theorem for that. Let's consider the first condition. F of x is defined and continuous. Is it defined and continuous? Yes, it's a polynomial, right? The polynomial functions usually defined one. If you give 0 or 3 or any in between value, you will be getting some values for f of x, and hence f of x is defined and continuous in the closed interval 0, 3. And the second one, f dash of x, right? F dash of x. F dash of x is equal to 3x power 2 minus 2. 3x power 2 minus 2 is also a quadratic polynomial, and hence this is also defined in the open interval 0, 3. If you give any value in between this interval, you will be getting some answer, and hence f dash of x is also defined. As per the mean value theorem, there exists a point c belongs to a, b. That is, there exists a point c belongs to a, b. A, b in the sense it's 0, 3, such that f dash of c is equal to f dash of c is equal to f of b, and hence it is f of 3 minus f of a, hence it is f of 0 divided by 3 minus 0. What is f dash of c? Already we found f dash of x, 3x power 2 minus 2. So f dash of c is 3c power 2 minus 2 is equal to f of 3. What is f of 3? Put 3 in place of x, and hence it is 27 minus 2 into 3 minus 6 plus 5 minus f of 0 value. F of 0 is by putting 0 in your f of x, which will give 5 divided by 3 minus 0 is 3. And hence it is 3c power 2 minus 2 is equal to, this 2 will be cancelled. This is 21 divided by 3, which is 7. So 3c power 2 is equal to 7 plus 2, 9, and c power 2 is equal to 3, and c is equal to plus or minus square root of 3 and plus or minus 1.732, the value of root 3. Now let us check c is equal to plus 1.732 belongs to the open interval 0, 3. Open interval 0, 3. Here it is 0, here it is 3, and this is 1, this is 2. 1.7 will be here, okay? And hence the value what we found as the value of c is in between 0 and 3, is in between 0 and 3. Hence this is the value of the c by mean value theorem, and hence the mean value theorem has been verified. And in a similar way you can go for some other functions to check in the same method. See you on some other lecture. Till that, see you and bye.